This is example 3D in section 4.7. So in this rational equation, we want to find the derivative. So one of the suggestions could be that you could use the quotient rule because we have a numerator and a denominator. However, I'm going to turn this into a product instead. I'm going to make this binomial an exponent -2 by bringing it to the numerator. So now I created a product. So to get the derivative, we're going to start with the product rule. You take the first function and you multiply it by the derivative of the second function. So when we get the derivative of this function, we're going to use our chain rule. So we have an exponent that we're going to work with first. So we have -2 bracket 4 minus 5x. You subtract 1 with the power rule, and then you go back in and you get the derivative of the inside function, which would be -5. Plus, you continue with the product rule. You take the second function and you multiply it by the derivative of the first. So the derivative of 2x is just 2. So the product rule is finished, including the chain rule. So now all I'm going to do is tie it up a little bit. So I know I have a 2, a -2, and a -5 attached to this x. So 2 and 2 is 4 5s is 20. So I'm going to get 20x. Now this exponent attached to this binomial is negative. So I'm going to turn that into a positive exponent by flipping the base. And then I have 2 by itself. And again, I'm going to move that exponent to the denominator to make it positive. Now I do have similar denominators, so I'm going to get a common denominator. My common denominator is going to be the highest exponent, which means I don't have to do anything to this term, but I do have to multiply this term by another 4 minus 5x so that I can get that cubed. So when I multiply the 2 by the 4 minus 5x, I'm going to get 8 subtract 10x. And then I just combine the like terms. So I will get 10x plus 8 over the denominator. And if you like, you can take out a 2 to give you 5x plus 4. The benefit of trying to factor is for anything to cancel. In this case, it does not, but there's no harm in taking out a common factor. And we're done.